Good afternoon for everybody. Welcome everybody. Yesterday we had to start with the class where we have covered the 3 important modules. Today we're having another 4 modules. Each of these modules are also important. You are going to add on the knowledge you gained yesterday in learning how you do data flow diagram modeling and how do you do also an ER diagram. On the 3rd module of today, we're going to talk about CRM, okay, and how CRM is very important for business competitiveness. And the last module is about knowledge management. And knowledge management is a very important area. You hear now a lot of people talk about it. We'll talk about what is knowledge management, how you create a knowledge, and how you empower your organization to create knowledge, utilize it, disseminate that particular knowledge. So we will start with today's module. Today's module is module number 4. We are talking about the process of modeling, and in this module we're going to cover the data flow diagram. At the end of the day, everything we want to develop a software or a system, we are reflecting something called a processes. Once we do the processes, we understand what we want, we develop a model. So in the model is nothing more than a representation of the reality. So we develop a model for medical information system. We develop a model for student registration system. We develop a model for banking system. So a model is a representation of reality. In a sense that it's always the best practice to develop a model is to develop it in a visual representations. Why? Because visual representation, it does reflect what? The reality. It's rather than a written statement of word. So as you see here, it says a model is a representation of reality, just as a picture worth thousands of words. Models are picture visual representation of the reality. We create in information technology a model called logical model, and we have another model called physical model. The relationship between what we call it the logical model is that it's independent of the hardware, independent of the technology you're going to use to develop the software. The physical model is dependent, related to the hardware, to the tools that you're going to use, to the language you're going to use. So basically we start with the planning, then the analysis. And from the planning and the analysis in system development life cycle, we understand what we need to do, we understand the requirement, and then we do what we call a model. Logical models is basically shows the processes and the flow of data and the external entity. In this case, we call it data flow diagram. If the model is a logical model, is showing entities and the relationship with the entities and the attributes, we call them ER model. Once we create the model, we go on implementing the software, and we have to define what technology we want to use, what kind of programming language. That means we depend on technology in order to what? Implement, to come up with something, to execute, to develop the program. We call that physical model. So a physical model is not only a system, okay, but also is a physical components which is depend on what? On technology. So we call that implementation dependent. Why we call it implementation dependent? Because it's depend on the technology we use. An example, if you are going to execute your program using Visual Basic, so you use a technology called Visual Basic. But if you are using the same program, you want to do it in C language, you are using C language. If you use C sharp, you're using C sharp. So therefore, technology is dependent. That means you are executing the program, developing the program based on technology. So once again, we have a model, which is a representation of what we want to do. That model, we have it goes into two categories: logical model and physical model. Logical model is independent of technology. That means it's like you're doing what? The diagram for your house, the blueprint. In this case, you have not really select the concrete, the cement, you did not select the wood, so it's independent of the material. If you are going to execute it, build a house, mean you have to select what type of concrete, what kind of bricks, what kind of wood, mean you are dependent on the material. In information technology, we relate the first one to logical model, the second one we relate it to physical model. Now, usually what we do in modeling, the first things we need to understand is the process. And a process is a formal way of representing how we really process a business model. We discussed this in the previous module. We said a process for ordering. Okay, a customer placed an order. If it's a manual base, so maybe it's required many processes. When we automate it, we say, can we eliminate some of these processes? Are these processes can be replaced with a very innovative concept? We discuss that by doing either business improvement, automation, or business process re-engineering. That will result for us in having a very well-defined process of how we are going to conduct or do customer order. So a formal way of representing how business is operate, we call that a process model. Example, in a university, you have the process of registration. A student enroll, students select a program, student select a course, attend a course, do the assignment, get the grade. So that's the process. Within each one of these, there are registration, there is a sub-processes. The data flow diagram, okay, is a popular technique of modeling. And why it's a popular technique of modeling? Because it shows me how the data is stored. In other words, data is initiated from whom? From a person. Could be a customer, could be your business partner, could be a supplier. We call that external entities. That customer, basically when he interacts with the system, he is basically getting the data into a process. Example, when the salesperson place an order, execute an order, so you have an external entity called salesperson and the data flow to a process, that process called customer place an order. So the three elements in a data flow diagram is one, external entity, the entity that's going to give is the source of information. The second is the process, what we are trying to, the program. And we know that a program need a data, okay? And then we need to store it, and that we store it in a file. So if you go to your calculator, when you use a calculator, you want to compute or you want to multiply two numbers. Example, 2 plus 3. So you are using a program called calculator. When you do a data flow diagram for calculator, we need two things. We need first to see how these numbers is gonna be entered. So they are going to be entered by external which is the users. So you will add first number, second number. Then the calculator is a process, which is what? You telling what is the desired. So that means you will add 2, and you will add plus, and you will add 3. The process is the calculation. The process here, what they will do, will take those 2 numbers, identify it's an addition, will add them, and then this number need to be what? Displayed. So that is called output to a file. In this case, in data flow diagrams, we have a primary representations of the components. We have also a logical graphics models, which shows the 3 components. In a very typical data flow diagrams, we have these 3 major components. The first one is the process, which is actually adding 2 numbers. Could be registering a guest in the hotel, making an appointment for a doctor's, placing an order. That's a process. The process is coming from external entity. In this case, the person who initiate the process. And that person is going to give us a data, the arrow, and that data need to be stored in a file. So if you remember yesterday we discussed, we have input, process, output. So think about it. The input is the external entity, which is the arrows is showing the directions of the data in or out. The process is the program, and the output is we need to store the file in a file. We have the different school of representation. One school is by having the process in a circle. Another one is in more optical, Olivers. Another one, we have the data file. In this one is done as 2 lines with the data file, name of the file, like customer name, course name, student name. Here we have a process ID, so we number the processes. Here we have the data store, and the numbers mean the numbers of the file. And here we have is the external entity. All these are different style or standards which is used for data flow. Now, in the data flow, we have the following. We have a process, which is activity or a function to perform for a specific business reason. In the examples of the calculator, the process is adding a number, a calculator. So that is a process of a calculator. In the flow is the directions how the data is in the process, feed into the program, or the output from the program. If you look at Uber, you know Uber, right? The car. If you want to model the data flow diagram for them, you say Uber as a circle. So that's the Uber information system. Now Uber, the model its work is very simple. This is Uber. And Uber is basically wants to develop a system. That means we have to understand the business model of Uber. So what is the business model of Uber? Anybody knows? Very simple. A drivers which will say, you know what? We would like to be part of Uber. Customer who wants to have a request for a transport for a car. Upon that, these guys, here is a customer searching for transportation. Here is the Uber, which is basically the drivers. They are basically have a contractual agreement, which they say, you know what, we want to offer you our service. And then what the customer select from customers is requiring from Uber to have a transport. Ubers will basically identify who are of these drivers, they are registered with me, able to take what? This customer. Upon that, Uber will collect the money and pay what? The share to the driver. So in other words, this is, we call it the context diagram, which is the highest diagram, which is what we want to do. We want to do Uber information system. So that means the company Ubers, they want to create a system, and that system called Uber information system. Now, the model is, here is a customer. So, customers is what? Is an external entity. Now, we have also the drivers is an external entity. And we have money goes to the banks, the payments is an external entity. You got it, guys? Now we need to understand the interactions between each one of these guys. Very simple. Customer make a request. Agree or not? So basically when you are using Uber, you're making a request. I am in city center and I want to go to where? To the airport. So you make a request. So that's it. That's mean the flow of data initiated by the external to the Uber. Now, what's basically customers is giving here is giving an information. Example, customer name, location, destination, agree or not, type of car. So all these are datas that is the customer is going to feed to the Uber information system. Now Uber will do what? Will take this information, wants to identify for us who is the appropriate driver. In this case, Uber is going to send to the drivers, where the driver is going to say, you know what? Here, Uber goes calculate and look at the drivers, know that here, who are the driver, who is appropriate for the car that this person desire, and where is their position through GPS. And then, based on these parameters, they will select to the appropriate drivers. In this case, drivers is an external entity, and the drivers who desired, okay, you are candidate to pick him up. She's candidate, you are a candidate. So now the driver will do what? Will feed in a data to say what? I accept. So now we have two directions of the data. One direction is coming from the customer to where? To the system. Another direction of flow of data is from the system to the driver. And upon the driver accept or reject, or decline, here we are sending to get the appropriate driver. Upon that, he accept, that means the data will come from the driver to here. The drivers, the customer will be told that it's going to come for you. Upon the service of the driving, what's going to happen? The customer is going to pay. So that means payment will be going from where? From the Uber system to credit to the bank. Now we want to pay the driver his share. Agree or not? So that means from the bank, okay, from the bank it goes to whom? To the driver. In other words, it's going to go through who is going to tell them? The Uber system is going to credit the driver, okay, for the amount of money. You understand, guys? In other words, now here the bank is going to say, you know what? This is the money to be deposited to this driver. Now, in this case, we have defined three things. We defined what we call the process. Okay? We defined the flow of data in and out, the direction. And we defined, again, what we call the external entity. But in this example, we did not really define the storage. Why? Because this is the context level. That means every information system starts from context, means from the higher level. When we go to the process details, that means a process of an order. Example, here is student, okay, or a customer is what he wants to do, place an order. Place what? An order. So, place order. This order, customer will feed in what? The name, the address, all of that. Now, what it's needed, we need to get, example, to verify if this customer is already exist or don't exist in our system. So we need a source of data to access a file. This file called customer file. Agree, guys? Now, upon this customer exists in the system, we go and we want initiate placing the order. In this case, this is placing the items order. It will go to another file, and this file we call it customer order file. You understand, guys? So in this case, now I have two things. I have the flow, the external entity. I have the process, two processes, and I have the flow of data, and I have what we call the data file. In this case, a process could be a system. A system is a collection of processes, okay? And each process could be into a sub-processes. Example, we can have inventory system or point of sale system. Within point of sale system, we have a process called registering a customer. Another process is what? Placing an order. Another process is receiving an item. In the process of receiving and registering a customer, I have sub-process. I have adding a customer, modifying a customer, deleting a customer, okay, printing customer report. Then in the case of inventory, I have adding an item, receiving an order item, printing an item, modifying an item received. In this case, a typical system starts with the following. It starts with the highest level, then it goes to a sub-level functionality, and each function, it goes into what? A sub-function. So if you look at a system of student registration, so we want to do a system called student registration. The highest level is the student registration. We call it what? Context diagram. Within this system, we have three major what? Processes. One is a process registering a course, registering a student, and one, for example, a teacher assigning a course for a faculty. And within registering a student, we have adding a student, modifying, and deleting. So if we go to the order, we have an order system. We look at the major components, items, customer, okay, order. Within the customer, what we have, we could add a new customer, we could modify a customer, we could delete a customer. In this case, we call this decompositions. That means we start from the top, we go into details. So this is the system, and from the system I have processes, process 1, process 2, process 3. This is a process 2.1, 2.2, 2.3. In other words, these processes belong to this process. Okay? We call that, what we call it, modeling of the system using a data flow diagram. Now, data flow diagram is a piece of data, okay, that has to flow into the process or flow out from the process. Always start and end. That means I have here is a process. This is a process, and this is an external entity, student, and I want now to register a student. Either data feed in from student to the process, or from the process to the student. Example, if the student wants to see his address, so he is extracting the data from the process to where? To the screen. That means this process is a program. A program to bring your address, to bring your grade. It has to access what? A data file. So that means if tomorrow you want to change your address, okay, in student registration system, what do? You are, as a student, you go to a process called modify address. You will query on your ID and so on. So the program will go and access a file called student file, and this student file will bring the data to you, and then you modify it, it will go back, store it. In this case, we have a start and end. So now let's understand. Data store is what we are storing the data here. It's a collection of file. It's a collection of data that is stored in a way. It could be stored in a file. We call it in database in a table. Data flowing out from the file and in. So either you are storing, adding data into the file, or you are retrieving the data. The data, it could be for update or for adding a new student. The external entity, it could be a person, which is a student. It could be a university. It could be a government organization. It could be a supplier. It could be GPRS in this case. In Uber, it's very important. They need to get what? The GPRS, your location. So one of the external entity for them is what? They link to the external entity called GPRS. National Library is very important for them, that they need to have online cataloging library. So one of the external entity is that they link their system with whom? With external databases. Example, ProQuest, Episco, and so on. You have a hotel system. One of the external entity is what? The banks, when you make a payment. External entity is what? The geographical system is to get what? The location, the Google map, so customer knows how they come to your hotel. So external entity is a person, a customer, student, okay, an organization, a bank, central bank, government agency, university, anything that stand as an external. Okay, it could be an external databases, could be CIO, okay, central statistic. Example, when you are in the banks, you give your CPR, they access it, it is external. If your system is connected to the benefits, so benefits will be external to the system and interact. So that means in any system, okay, we have here, if you look at it, a system like Uber, they have a system, but they need to interact with external body. One of the external body is what? Is the bank. Now, we have more descriptive of these names. If you look at it, we have the process, and we model the process by name. We have the data flow diagram, is the direction of the data. We have the file name, the name of the file, customer, order, student, courses. And we have the external entity, which is a bank. So in this case, programs are always an add-on activity. Example, like the calculator program is a process. Computing program is a process. Calculating the total of an order is a process. Placing an order is a process. A process needs to get data. That data is taken from external body, so we call it that external. This data after the process need to be stored, so we store it in a file. The arrows, which is the data flow, shows the flow of the data within the process, in or out. Now, we call these processes data flow, data storage, and external. Now, the data storage could be anything, any file, student file, customer file, item, inventory, anything you store. Could be also student registration, student grade, could be employee assignment. So anything reflect what we call activity. This is a simple data flow diagram. What we have here is a simple process, which is a club member. Somebody have a membership, and this club members is placing an order, okay? And you could, for example, you have a membership, okay, with ordering books. So you have a membership. If you have that membership, based on the membership, you get a discount. So you place an order. So here is the external entity, is a member, order, response. He is placing an order to a process called ordering process. Process member order. Now, this is a process which takes the customer name, takes the items he wants to get, the order. Now we take this order, the data of the order, we need to store it. We store it in a data file. Now here is the customer. We need to check whether he have a credit or not a credit, okay, for this order. In this case, in this process, we'll go check if it is he has a credit or he can cover his limit. So we go to the account file, and from there it feed in to the process.
It has to be two ways, right?
It can be two ways.
Okay.
Bringing, in this case, the process is retrieving.
But how does the database gets the like, how is it initiated?
Yes, here all the process is calling a function.
Okay.
say, get me for this customer 53, whether he has a credit or not.
So it's in the process.
It's in the process. Now, we also need to give, after he plays, we need to give what? Here, a bonus. So a member wants to search his what? Bonus. How much points I have? Do I have enough point? Like frequent flyer. So here is a member again. Interact with the program process called what? Process bonus order. Now, that means we'll go to where? To the account, see his how much credit he have. Now, again, this order is an automatic process which is going to say, go and get these items from the warehouse. In this case, the customer's order will be associated with an external entity called what? Warehouse. In a very simple terms, we have here is a data store, again like Uber, customer. We have an Uber system here, and we have an external. You could think about it, you have here is a banking system, and a banking system has what? A customer, and a customer, okay, in this case, a customer here is an external, okay, and here we have a process, it's called customer order. And in the customer order, what we have? Customer. A customer will come, place the order, you go check whether we have an item or not, or maybe in the data storage, we will store the order of the customer.
Can you go back to the previous slide?
Sure.
This process is parallelly happening two places.
Yeah. The one is from
Yes.
club member and then the from.
The process, if you are here, it's one process. Okay? And this is another process. Think of it that this is a program and this is a program. So think about it as a card. Okay? This process can call this process. Okay? And this process can call this process. But this process, before call this process, it need data and it need to compute to call this. Example, I have a person. I want to know he has test 1 and test 2. So I have a process which is says faculty enter student test. So enter test 1 and test 2. The process is adding the total mark for the course. Now I need to know, is this student under probation or not a probation? Okay? In other words, I go check based on his total mark, is he under high risk or not under high risk? So again, I call another process which is check for me what? The risk factor. So there we have one process which is adding two numbers, and this process is doing what? Adding what? Checking whether he is a risk or not. Now I have this process, the two numbers, I need to store them. So I will store them where? In a file. Okay, now that means a process, which is the core, this is a process, data has to flow in, come into the process. So they have to come in from where? From somewhere. Either come from a human, employers, employee, salesperson, student in this case. And then process is mean computing. We do something, we add two numbers, we do computing activity. The outcomes, the output, we need to store it. So we store it where? In a data file. Upon the data is stored, what we do? We could place another order. So for example, you have a customer wants to place an order. The first things I need to see, is this customer eligible or not eligible? Once he's eligible, Then what I do, I start the activity of receiving his order. When I start the activity of receiving an order, what I need to do to store his order. In this case, I have an external entity called customer. He put his customer ID. We checked to the file. He has a credit or not. This process will tell me he can proceed with the order or he cannot proceed. He does not have an outstanding, so we can proceed. So this process, we call it verification. This process, we call it what? Placing an order. Second process is placing the order. Placing the order means we know the customer number. We go and now we get from the customer, for example, the item he wants to place. So we have again a flow of data from the process order to the customer. He feed in the data for me. I go now and store the details of the order. We call this data flow diagram. Why it's very important for a business people to understand? So they understand how the data is initiated, which process do what, and where it's stored. When you look at this, you understand two things. You understand that there is a process called placing an order. You understand that there is a process called checking the bonus points. And there is a process called automating the order. We know now there is two data file. One data file called order and one data file called what? Account. So in this case, we identify that there is a process. In this case, you want to register for a course. So you are a student. A student wants to see if there is a course or no course. So this process called what? Acquiring 4 courses. To acquire 4 courses, need to go where? To a table has a list of courses available or not. So the data will go now flow from the course file to this process and then coming to you. Okay. In this case, this is the simplest data flow diagram components. We have external entity, we have the flow of data, and we have the process and the storage. Yeah.
Very nice what you said. But I have a question. When external entity initiate an inquiry, so first the arrow should go from external entity to the process, right?
Yes.
And then from process to the data store to check if there is this available or not. After that, data store will go to process and then it will come finally.
Completely right. What you said is right. Why? If you look at it, this one has what? 2 arrow. Yeah. Customer, what he is doing? Sending to Uber. Sending. This is my account number. I am in this location. I need this kind of car. Sending. Uber process. During this, they go check the driver who is. Then the driver says, I am available. They send back to him and they say, your order is confirmed, somebody is gonna come take you this long. You got it? So that means that the flow of data is 2-directional. Okay, one direction is from the external entity to the process, because think about the process is like a program you need to key in. And from the program to what? To you. Sending to you. Example, your order number has been confirmed, reference number 5059. So in this case, that data were extracted from the student table, item table if you want to call it, through the process, then the process returned it to whom? To the student.
So what I am understanding by this one, either it should be 2-side arrow or data is telling to the process that please float an inquiry to the external entity that we have this.
In this case, is only displaying. No.
Yeah, that's what I'm saying. It is not saying, this diagram is not saying, I don't know, that external entity is asking for inquiry. It's showing that data store is already having some information and he's plotting it to process, and
So
then
this is
process
the
is telling to
opposite
us.
The opposite.
Yeah.
This is one way, showing the external entity what are the items we have.
Exactly.
Yes, yeah.
And the last question that I have from the previous slide is like we have club member there and the club member here. I don't understand why we are using the same entity twice.
Because this club member directly interacting with whom?
Bonus person.
With the
So
bonus.
we can't have the arrow coming from there directly to the process.
You can, if this process, see, in
It's two processes going
two processes,
which is going into order.
So initiating by two different club members.
two different clubs. You can check your address and you can check your course availability.
But we
Two
can't have
different.
two processes in
Of
one
course,
process.
it's based on the modeling.
Like two different initiations at the same time.
Yes, you can. For example, you can have what? You can have, in this case, you could say, okay, club members, you see, place an order, then after, upon confirmation of order, get here the bonus, and again, in this case, you don't need this guy to interact directly. Okay? Now, here is another example. What we have student registration system. And the student registration system, we have what? A student. And here is a student wants to select what? A course. So that means a data coming from student initiated to the system. System coming back and showing what? The schedules of the student. Now here we have what? We have also another unit, which is the business office. It's another users, accounting office. What they are, they basically wants to have the details of who are the student who's registering. Now, in another word, we have what we mentioned, context diagram, which is, this is the context diagram, is the highest level. After the context diagram, we go to the processes, major processes. And after, within each major processes, we go to sub processes. So, example, point of sale. We have customer registration. We have customer order. We have item receiving. Within the customer, major process, what we have, sub-process. Adding customer, modifying customer, deleting customer. In this case, we could have level 1, level 2, level 3. Each process can be broken down into what? Sub-processes. And each sub-processes go with the same thinking analogy. Here is another example. The other example here, we have an entity. This is a data flow diagram for email university registration system. Here we have a student. And this student requests a course. So he is what? Requesting. We call the first process, because each process we want to give it what? A unique number. So we give it 1, 2, 3. Okay, guys? It's only a unique identification. Now, a process has a name which reflects what it is doing. So, student requests a course. The process here, we give it a number, 1. Verify the availability of the course. To verify the availability of the course, what do we need to do? We need to course file. We go to course file. Get the data, what are the courses available. So again, we have an external entity, we have the direction of the data flow, we have a process, and here what we have, a data file, and shows what is the data file is doing, is bringing what are the data, what are the courses available. Now upon that, within this process, okay, there is what we call a conditions, accept or reject. Accept or reject the selection. Mean he brought for me that course project management is available. So now what I do, I accept that, select it. It's part of this process. You understand, guys? Now, a process can call another process. All right, guys? A process can call another process. So in this case, a process means a program can call another program. This process is calling this process. What this process? It says enroll student. Now I am enrolling the student to a project management. So I am enrolling the student. What do I need? I need to have a student master file, which says that this student is enrolled in this course. So in this case, I need the course details, information about the course, which is course name, course ID. So this process will get the data from this file. So process 2 will go to course file and say, give me the course name and the course code. And now here will say, you know what? Course enrollment. It will do what? Update. So again, it's taken. And now here we want to put part of the student registration that this student is taking this course. So again, if you see that the data is going to be updated, written to the master student file. Now we are doing what? Registration. So after we enroll the student, we need to confirm his registration. So again, this is confirmation letter. Okay, it's an automated process sent to whom? To the student through email, through whatever, or a letter, or whatever. You see that? This is showing two things. It's showing 1, 2, 3 processes. It's showing one external entity, which is a student. It's showing 2 files. It's showing the direction or the arrows or the flow of data, whether the data are coming into the file storing or retrieving from the file. Are you happy, guys?
Yeah.
Good. Now,
So I have a question.
please, yeah.
Now, student requested the course, verify availability.
Yes.
Availability goes and checks in the course file what open courses are there.
What are the courses available?
Available.
Yes.
So, verify availability should have an arrow going to course file, isn't it?
Verify, which one?
The first 1.0
Yeah.
should have an arrow going to course file first, check, open courses, go back to them, right?
Yes.
So there is no need for the arrow going to the course file.
Process, say, go to the course file and what? Bring.
Bring what open courses are there.
Yes.
So
That's
there
what-
should be an arrow going that way or
To request, no. It's only bringing.
only bring.
When you request, when you're writing,
Okay.
when you are writing,
Okay.
you are only reading. You're not writing. Okay, guys? Clear?
Update and add will go to
Yeah.
database and retrieve.
Yes. Update, modify will go to the file.
So the
Read.
request is just the
Read, only reading. Yes. Okay, guys? Clear?
Now,
That's the reasons what we're doing here, my friend.
after registration is done, now of course the other process will start, which will connect it to accounts, right?
If there is in the model.
Yeah.
If we add, yes. That's the reason we say, see, in data flow diagram, we say, for example, external entity cannot talk to external entity. In other words, this is a customer and this is what? Let's say supplier. They cannot talk. What we need? We need a program, a process. Okay? In the middle. So they will talk together through what? A process. Okay? These are rules of data flow diagram.
Okay, so that is why the request for the course, it comes in the verification itself.
There must be a process. But a process can talk to a process. Yeah. Okay, guys, clear? All right. Now, it's difficult, but I'm trying to make it easy. Now, let's look at this one. This one is a order system. And the order system is, again, this is a customer. Okay, what customer do? Placing an order. An order goes to where? Read the customer record to see whether he's active, whether there is an outstanding, get a credit approval. Then it goes to where? It goes to the inventory, which order he wants to place or which item. This is again very simple high level one. Okay, guys?
Very simple and high level also.
Yeah. What's this?
Perfect. Context level.
This is a context diagram, but it's the same things but more descriptive, like this one.
So in this one we don't have files involved.
You don't have file. This is the first what?
Context level.
We start always with the data flow diagram starting with context diagram. After context diagram, what we do? Start with major processes. Then each process we look at it, we say, is this process can be broken down into sub-processes. Example, customer, all right? Registration. What is the student registration? What is the sub-process? Adding, modifying, okay? Deleting. Process called order. What is the sub-process? Adding an order, modifying an order.
Returning.
Thank you. Returning an order based on your business model. That's where we start. Okay? Now, let's assume in the canceling of an order, we have, you remember, order, cancel, add order, modify order, cancel order. In the cancel order, we want to cancel it now. There is another process. What it is? Return tax, transfer money to the bank, penalty, thank you, get approval, whatever it is. You understand? It's a very simple logic. This is patient information system. Happy? So when you go to the hospital, there is a system called patient registration. Well, you could replace this to what? Banking information system. Library information is the same token. So this is the name of the system. Uber system. Look at that. What we have? Patient. What we call that, guys? External? Thank you. Doctors. What we call that? Insurance company. Now what we are showing in this one, we're showing the relationship of these guys with the system. You got it? In other words, patient information are fed to the system. Patient wants to have to see what is a possible appointment vacancy. Patient wants to change their address. Patient wants to have create an appointment. Patient, okay, cancel an appointment. Patient wants to pay payment for the bill. Okay? Doctors, what he wants from the system, he wants the list of his appointment list. Only he wants appointment list. He go get it from the system give to the doctor. The system also, he wants to see how much money you get. So in this scenario, doctors are not what? Inputting. Usually doctors are like that. Now, insurance means that after you get treated, hospital wants to get money, right? So they send to insurance. AXA, 360, NextCare, whatever. Now the insurance, we need to send insurance. What we send, the system will do what? Send a bill. Insurance will do what? Payment. So that's what it is. What we have here, we have now within the system the major processes. Let's look at the major processes. One process say find a patient, means search a patient. Another one is look at this. Patient name, you go search by telephone number, by name. This patient exists in the master file or not. Okay? So what they do, again this process, okay, will go to read from the patient information system. Okay, doctors here wants to get what? The printing. So again, this is a process, say print for me my what? My patient list. So again, it goes print for him the patient list. That means go find the patient, read it from the file, bring it to this process, display to the doctors. And here is update. Here is look at that. Patient, look at that. What he's doing? Adding to the patient. So that is adding. So now if you remember, we could take all this, we call it patient registration. We discussed that. Now, another way of doing it, I come now, one, finding a patient. I say, okay, 1.1, 1.2, 1.3, 1.4. Mean I am now doing what? Going details of it. So in this case, 1.1 is checking patient status, 1.2 possible appointment, 1.3, and so on, canceling. Now we discuss the balancing. What's mean balancing? The balancing mean that if I have a process here, 2.2, there must be 2. Okay? We call that business process are too complex. What do? We do decompositions. We break them down. So we break down from 1, 2, 3. And we said 1.2, 1.2, 1.3, and 1.1. In other words, we call this a child, and we call this what? Parents. So how we go on step of developing what? A data flow diagram. First, we do the context diagram. You remember Uber?
Yeah.
Then after that, we create, okay, DFD for each scenarios. Example, what is our scenario business model? We have customer. So we register the customer. We have order. So what we do? We have an order process. We have what we do? We have delivery. Then after that, we go in each level and we break it down into the other level. We start with the context diagram. Then we went to level 0, level 1, and level 2. If you look at it, 0 is the context, 1 is the level 0, 2, here is 2, 2.1, 2.2, 2.3. Within 2.2, we have 2.21, 2.23, 2.2.3. Now, if you look at it, we have a process calling a process. You understand? Okay. Again, first we start with the DFD of every process we do. We show the context, then we show the overall of the process. And if this is in the context diagram, what we done, we have the entire system, and we said what are the externals body. This is a context diagram. This is level 0, level 1. We discuss what is level 1, which is, we discuss what's level 2. Now, we are going to something in modeling called what? Decision tree. You remember we have check if exists or not exists. Is it a decision or not a decision? Decision. We have a collection of a process. We want to know which process we call. So here is a new patient. Well, what does patient want? A patient want to do an appointment. So the first things we need to do is to check if this is a new patient or not a new patient. If it's a new patient, what we do? We add a record, register the details of the patient. We ask him for his address, for his next of kin, okay, for his name, and so on, and we do patient registration. So in this case, we see, is this patient is a new or not a new? If it's a new, what we do, we call process number 2. That process called what? Add a new patient. What's the second one we do? If the patient exists, that means we have a record for him. Our business model says, before you give an appointment, what you need to do is there is any outstanding. So we say any unpaid bill. If there is unpaid bill, what you do? Transfer to process. Example in this case, to what? To the business office to pay. Or in this case, what I do, I call a program, say, pay your outstanding. So you understand now how the process is related. If there is nothing, zero outstanding balance, what I do, I schedule the appointment. Okay, let's convert this to a business. I have a patient, I have a guest wants to come to the hotel. All right, guys? Or I have a person wants to place an order. So here I have something called customer, right? So I go check whether it's a new customer or existing customer. If it's a new customer, what I do? I register his details. If it is existing customer, what I do? I go check, okay, the balance. I will call a process called process 3, check customer outstanding. To that process will do what? Will access a file, call it what? Customer credit. Agree or not? Account. File will see yes. Then I will say payment has to be done. You seen that? If the customer there is no outstanding, mean here what I do, he proceed with the new order. Now the benefits of data flow diagram for us business people, we could see how the processes are what? Connected together. The beauty of it also, we see the decision rules. In this case, we have a decisions. So we do a modeling. Okay, we structure the data flow through the system of the processes. We have a way of looking at it in a like this one: file, data in, data out, external. There is a difference between a data flow and a flow chart. Flow chart. A flow chart is showing me the flow of things with what? Conditions, control. So processes on a flow chart execute at a time, one time. If then, if he this, then that. Where processes is what? It can be execute based on what? In parallel, or it could be you execute based on data driven. System thinking means a system thinking is the application of a formal theory and concept to system problem solving. Mean I'm trying to understand how I solve this problem. I have a problem, people place an order and they have what? An outstanding. So what I do, I use system thinking. That means I check whether there is an outstanding, a decision tree, what we done. If there is an outstanding, then you have to pay. If there is no outstanding, then you proceed. Again, if you look at it, what I have, we have an input, we have a process, we have an output. An input comes from an external, it could come from a data file. A process is a process of computing. An output could be, again, goes to the external or goes to whom? To the file.
Or to another process.
Huh?
And to another process.
And to another process. That's exactly, yes. Now, a process can call itself. Example. I want to give you, you enter a wrong ID, password. Would they give you a trial or not? So, agree or not? So this process called logging in. You enter the first one, then give you second try, third try. Okay, the condition here, the business rule, within the process, it says, if it's more than 10 times, what you do? Lock. Now, how many of you use a banking system, email? I use BBK. Whenever you log on to BBK, online, what's happening? You get SMS. So look at that. The logon process will call another process called send a notification. Beautiful, this one. That SMS is what? External entity, which is SMS exchange server. Okay? And then sent to your mobile. Very simple. Look at that. Yeah. Very simple. In this example, okay, you log in. So you have the business process work like that. Customer, login. Thank you. Upon successful login, what you do? You send SMS message. Agree or not? Thank you. So what's happening? Here is a process which is login, process 1. Will call another process, which is what? Process 2. This process 2, what will do? Will go to external entity called SMS IPX server. Thank you. That's what is really called. That's an external. And that's what you get, right? Now, login. What do we need to do in login? I thank you, but we need to keep track, right? You see it in BBK Bank, because I use that. your last login. So this login will go to where? To a data file called login transactions log. Agree? Yeah. So now here is customer. Very simple. So now what we have, this is what we call decomposition. This is the system, and the system has functions, and this function breaking down into sub. You remember I talked about it? Point of sale, customer order, inventory. So that's it. Now here is customer, place an order. This order have how many processes? 3. Standing order, process rush order, standing order. This is when you use e-commerce. That means if you use standard, it will really call a process which is again no extra fee, whatever, different parameter. But if you're going to say rush, you have to pay extra money, all that, everything. And then they have to assign it priority and all of that. If it is basically a standing order process accepted, okay, this is standing order, this standing order, okay, is number 2, so is another model. Again, you have, this is an order. Look at this order. You place an order. When there is a new order, you create it. Agree or not? You write it to where? The order. You want to delete it. What you do, you update the file. You want to change, again, you change it to the file. You want to read. What's happened to the arrow? Outward. Happy? Yes, I know at the end you'll be happy. You'll be much happier with the another example. So this is showing you the directions that if data is in, you are writing, you changing, you modifying, the arrows will be inward. If you are reading, the data will be what? The arrow will be outward. We discuss about external, we discuss about data. This is another one. Now, what you have here, we call, I bring this sometime to my student in an exams. I bring this one, I don't bring for you guys. There is no exams. I bring this, okay, and I say, this is, tell me what's wrong. You understand, guys? The slide? This is the scenario. Okay? That means a process to a process we should not have. So what it is? Because this is, external entity to external entity. I cannot have without a process. This is also another one. A process is needed to update. In other words, this guy cannot go directly and update into what? Into the file. You need to have what? A program, a process. Again, a file, data file, cannot really communicate with whom? With the customer. They need a process. A file cannot talk to a file. They need what? A process. So again, if you look at it, this is a context for a travel vehicle. This is the orders and the relationship between them. These are the files. These are another examples, customer, order, and so on. All right. Let's do an example together. let's assume that you have a purchasing system. Try it yourself.
The example is from the workbook or from
No, from me. Okay, we'll do that. Let's look the workbook. Go to page number 5. Do you guys have in page number 5? Because I don't have the.
This is old book.
This is the old one, right? This 5. You have the new one? No, it's okay. Yeah, it's also 5. Everybody is lucky. All right, can you make a data flow diagram for a bank loan? Yeah, work as a team. First of all, can you think about you don't need to do the contacts here. You need to do what? Level 0. Mean after the contacts. The major processes.
Which one, sir? Which one? We didn't get it.
Number 5.
We have level 0 already.
This one?
Level 0.
Yes, sir.
No, that is for a student. You need to do what? If you read question number 1, draw level 1 data flow diagram for taking a bank loan. Yeah, you have to do.
So each one we will break it down.
Yes. First, you need to identify what? The major processes.
Context and data flow diagram sample 1, YouTube.
and supplier already copied over from our context type along with 5 data flows.
Application feedback.
Customer
This is
Officer.
application feedback.
request loan
Yeah.
application
Process application.
then it go to customer.
Everybody's happy? Okay, let's do one more. I will not ask you to do it. I will ask you to see. All right? So we will play now, okay, the Uber. So
do this time is look at